Good day, everyone. My name is Engineer Abdul Hakim. I'm an electrical engineer, and today I'll be talking about electrical code standard specifications, between some comparison between Qatar specifications and UK and US electrical systems. So this as a result of a request from one of my students. Then I wish to make it public for others also to benefit from this discussion. Firstly, installation is not just about cables or breakers. It has to do with compliance with code and standard. So every country has their own electrical rules. They have their own voltage system and safety authorization. Like when you talk about Kotor here now, we have Karama as in charge of Kotor standard and specifications. They have the standard to be 2018. This is the updated one till this video. And majorly, Karama is following British standard heavily. Most of their code, their specifications is based on the British standard. Possibly IEC and the rest like that. We have Qatar construction specifications. Qatar construction specifications, we have 2010, we have 2010, we have 2014, and I think latest one now is out, I think it's 2020, 2024 specifications. This is one of the best electrical code that you can apply in Qatar. It's been compliant and compiled with a specialist around 120 consultants for this code. Also, uh, other standards are there, be it from US, from UK. We have OSHA. We have OSHA, which is from British or IOSH. We have IEEE. We have IEEE majorly from US. We have um, we have Shell standard. We have Shell standard. We have Qatar Energy standard if you are in Doha. So, but now when we are trying to do, let me put Qatar Energy here. When you're trying to do comparison regarding the US or UK standard, let's say we have a UK, let me put it down, and US, right? Now, for UK, we have IEC, we have British standard, of course. And what about NFPA? NFPA 72. NFPA 72, we have NFPA 101, which has to do with life-saving code. Okay. But to be specific and to have some guidance regarding this code, firstly is standard or code are voluntary. Yeah, let me put it down. They are voluntary. They are not mandatory. Let me repeat my step. Standard are voluntary, they are not mandatory unless or until they are part of the law, unless they became part of the law, right? They became part of the law. So if they're part of the law, it means you have to abide by the law, right? So it means if it is part of the law, it means you have to use the specifications. You cannot energize or approve a design without following the rules according to the specification of the country, right? Like quick one, you like Qatar now they have the vote declaration to be 240 votes, right? We can see plus or minus 10 votes, plus or minus 6% according to Karama specifications. They have a frequency of 50 artists, right? 50 artists. Saudi is having 60. They declare their three-phase voltage system to be 415 volts. Let me say three-phase to be 415 volts, right? And the single phase to be 240. Let me put it down again to 240, right? So, country like Qatar, a country like UAE, UAE, country like Oman, yeah, Oman, Sudan. They're all following all this. Even Nigeria, they are all following this electrical standard for the voltage classifications. But when you talk about US, okay, when you talk about US, I think US, that is KSA King. Saudi Arabia is using US specifications, so majorly they'll be looking, they are following NEC, right? Which refers to National Electrical Code, right? So the voltage level we have 110 volts, and then for the three phase we have 380 volts for the three phase, and they have the frequency. They have a frequency of 60 hertz. So what are we saying here is it is important as an electrical engineer that you have to understand the code of the area you are trying to operate. So these are the code that the Qatar specifically followed. And as I said earlier, you can have, let me quickly look into, let's say, voltage classification, right? We have extra high voltage, right? Extra high voltage that will be above 132 kV, 132 kV. We have high voltage that will be within 33 kV to 132 kV. And then we have medium, right? Medium volt, which has to do with within 1 kV to 1 kV to 33 kV. And we have low voltage, where you have a lot of equipment. Within the low voltage, we have fire alarm systems. We have a CBS, central battery system. We have BMS, CCTV, access control, public address systems. They all fall in this category. Just to do between 25 volts to 1 kV. And then we have extra low voltage. Extra low voltage would be below 25 volts. Here we talk about 25 volts, talk about swimming pool or jacuzzi and the rest like that. So I will not try to make this video lengthy so that we can just listen to it and it again. But before I end the video, I would like to bring one comparison again, which has to do with IEC and uh, American National Standard Institute. They have their code in terms of symbols, but there's a little bit different. And I quickly bring it. Let's talk about transformer now, right? We have a transformer here. For IEC, you will be having the symbol in this format, right? This is transformer symbol. Let me put the data here and start connection here. um, healthy. Okay. Now, but for American standard, you have the winding coming in this format, right? This is one comparison, and then we just bring one another items like fuse, right? Like fuse for IEC, you have a fuse in this format. Let me just manage this side. You have a fuse, it will become like this in terms of symbol fuse for IEC. But when it comes to American standard, you have it in this format. You have it in this format. So when you check your shop drawings or your electrical design, so you have to also understand that apart from the specifications in terms of code, the symbols also differ from one another. So I would like to end the video now, and next time I'm going to talk about a single phase electrical system. Thank you for listening.